Hello. In this video, I'm going to look at some of the ideas of indices. In particular, we're going to be looking at powers of zero, and we're also going to be looking at problems that have involved fractional and negative indices, as well as one question which is much more of a modern style that's been added to recent exams. So we're going to be looking at the powers of zero, and to do this, I'm going to look at a pattern for the powers of 10. It doesn't have to be the powers of 10, we could have used any power, but if we look at the numbers on the right hand side and we look at what happens to them as they go downwards, we can see that we are dividing by 10 each time. And so as we divide by 10, it means that the next value that we're going to get in this pattern is going to be 1. And so 10 to the power of 0 equals 1. And this would have worked out no matter what power we'd have started off with. If we had 2 to the power of 1 before, and that would have been 2, we'd have divided by 2, and again been left with 1. So for any number that you have a power of 0 for, it is going to equal 1. And in fact, this is also true in algebra. So any term that you have to the power of 0, that is also going to equal 1. And a common mistake or misconception that is made is that powers of 0 will equal 0. So that's one of the things which you do need to be aware of, that that's not true, and that every power of 0 will always give you 1. The next bit I'm going to look at are fractional indices. In particular, this example here where we look at 36 to the power of a half. Now, when you have a fraction as a power, the numerator will always be a power, and the denominator will tell you the root. So in the case of 36 to the power of a half, the power is 1, and anything to the power of 1 doesn't change, so that's not necessarily going to do much. But because the denominator is 2, that means we're going to look for the square root. And so the square root of 36, that is going to give us 6, and it could be positive or negative. Most of the time in these questions you can get away with just writing the positive root, but it's always best to make sure you write both. Now, another type of problem you could get is where the fraction doesn't contain a numerator of 1. And so this time, going back to the idea in the top corner, the denominator is the root, the numerator is the power. Now, it won't matter which order you do this in, but it's always better off to start with the root, because that will make the number smaller, and then when you use the power later, it's a bit easier. You wouldn't really want to do 64 squared and then find its cube root. That's not going to be a very nice calculation to do. So if we write this one out as the cube root of 64, because the denominator is the root, we'll then want to square it afterwards. The cube root of 64 is 4, so we're going to do 4 squared, and that works out as 16. And so as long as we've got some sort of fractional power, we do understand that the numerator is the actual power, and the denominator will always be the root. So in this next example, I'm going to go through negative indices, and we've got 4 to the power of negative 2. Now on the right hand side, I've brought through the work that I did on powers of 10, where we showed that 10 to the power of 0 was 1. Now if I continue the pattern on both the left and the right hand side, we will be able to show that a negative power can be written as a fraction. And this negative power of 1 is the fraction 1/10, or 1 over 10 to the power of 1. And if we did the next one down, we'd get that 10 to the power of negative 2 is 1 over 10 squared. What this shows us is that our negative powers actually don't lead to negatives, but they do lead to positive powers where we put it in a fraction format. So what I'm going to do with 4 to the power of negative 2 is I'm going to write it as its reciprocal. So the reciprocal of 4 is a quarter to the positive power. So instead of negative 2, I now have positive 2. And if I take a quarter and square it, then that would be 1 squared over 4 squared, which would leave me with 1/16. And that would be my final answer for this one. The next example looks at, well, what happens if we start with a fraction inside or to a power, and this fraction to a negative power here. So using the ideas from above, I'd find the reciprocal of 4/5, which would be 5 quarters, but my power would now go from negative 3 to positive 3. And this is a pattern we can use any time when we're dealing with negative powers. So now I'd get 125 over 64, and I could write that as a mixed number of 1 and 61 over 64. There's not been a lot of mark schemes where it's made it necessary to change to a mixed number, but I've decided that I'd prefer it written that way, so I would always do that where I could. The next problem I'm going to look at is when your power is both a fraction and negative. So in this example from a paper, we've got 16 over 81 all to the power of negative 3/4. So what we're going to do is combine a couple of ideas from what we've had before. So I can get rid of that negative power by using reciprocals. So if I take the reciprocal of inside the brackets there, I will then have 81 over 16 to the power of positive 3/4. Then using the idea that the 4 is a root, it would be the fourth root, and then the 3 would be a power, so it would be cube. I could then write this as the fourth roots of my numerators and denominators, all then cubed. The fourth root of these numbers would then give me 3 over 2, all of which will be cubed. Now if I cube the numerator and denominator, I will then get 27 over 8, and again I would write this as a mixed number of 3 and 3/8. So this one just combined both of the previous ideas, and then that brings this all together. Now, although this is a piece of number work that I've done, it is quite possible that you could have this involving algebra. And the next example I'm going to show is going to bring a little bit of algebra into this work. So some of the more recent questions that have appeared in exams have been a little bit more complicated in that they don't look like the traditional problems that you've just seen. So here we have 3 times the square root of 27 equals 3 to the power of n, and the task is to find that value of n. So working with the left-hand side, we need to start writing it as powers of 3 as best we can. Well, 27 is 3 cubed, so the first thing I'm going to do is I'm going to write that into the left-hand side of the equation. Now the next thing I'm going to do is I'm going to write the power of 3, which is at the front. Now 3 on its own means 3 to the power of 1. And a square root will be a fractional power of a half. And then my question starts to look a little bit like this. Now, the 3 cubed to the power of a half, we have a power of a power. And one of the basic index laws would say that you can multiply these two. So I now have 3 to the power of 1 times 3 to the power of 3 times a half. Now it's getting a little bit complex, but this will then all simplify together. And as we start working through this, we'll have 3 to the power of 1 times 3 to the power of 1.5. When you're multiplying powers which have the same base, you can then add them. And so I'm now got that 3 to the power of n is 3 to the power of 2.5. So in answering the question, the value of n at the end is 2.5. And I'm sure it wouldn't matter if you wrote it as a decimal at this point, but I've kept everything as fractions this far, so I'll probably stick with that. Now they are writing new and interesting questions like this, so you have to be prepared to demonstrate your understanding of indices, fractional powers, and start writing out various bits of working. You might not be too sure of where you're going, but if you stick with these ideas, then you should be able to get some marks and hopefully all the way through to the final answer. So hopefully this video has helped with some of the ideas of indices. Thank you.